Alright, so this LeetCode question is called First Bad Version. It says you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API isBadVersion, which will return whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. So the example is, given n equals 5 and version equals 4 is the first bad version. When you call isBadVersion on version 3, it returns false. If you call isBadVersion on version 5, it returns true. And if you call isBadVersion on version 4, it also returns true. So just like they said above, anything after the first bad version, which is version 4, is also bad. Alright, before we start, let's go over a good way to find the midpoint in a data set. That is the formula left plus right minus left divided by 2, and you round that down. So let's try it out here. What's left? Left is the number 1, so that'll be 1. What's right? That's the number 7, so right here. So right minus left, we said left is 1. Divide that by 2, which will give us 3. And if it were a decimal, we'd round it down, but 3 rounded down is still 3. So that means our midpoint is 1 plus 3, which equals 4. Let's do it one more time with only 2 elements. All right, what's left? 1. What's right? 2. So 2 minus 1 divided by 2. So that'll give us 1 plus, what's 2 minus 1? That's 1. What's 1 divided by 2? 1/2. But remember, we're rounding that down. What's 1/2 rounded down? It's 0. So what's 1 plus 0? It's 1, which is right here. Alright, so what this question is saying is this. We have a certain number of versions of our product. Let's say in this example we'll do the number 7. So we have 7 different versions of our product. At a certain point, a bug was introduced, and after that happened, the bug has remained in our product. For demonstration purposes, we'll pretend that the first bad version was version 5. And as we see, that means that version 6 and version 7 are also bad. But how do we narrow down the version 5 was the first bad version efficiently? Well, one way we could do it is we can just start from the front. So, was version 1 a bad version? No. Was version 2 a bad version? No. 3? No. 4? No. 5? No. But that's not efficient at all. We're definitely going to go through each version until we find the right one. Imagine if we had like 1,000 versions and the bad one was on version 999. We'd be going through 999 versions until we found the right one. Or what we could do is to use a binary search. With binary search, we'll check if the midpoint is a bad version. If it is, then we know that either the midpoint is the first bad version or something that came before it. If the midpoint isn't a bad version, that means we can eliminate that entire half of the data set because we know the first bad version is somewhere to the right of it. So now that we've eliminated that half of the data set, we do the same thing again. We check the midpoint. Is that a bad version? In this case it is, so we know that either this one is the first bad version or something to the left of it was the first bad version. meaning what we can do is we can eliminate anything to the right of it. So now we do the same thing again. We look at the midpoint of these two numbers. Is this a bad version? It is. And what that means is that this is the first bad version because there's nothing to the left of this. All right, so let's do that a little slower. We have 1, 2, 3, 4, 5, 6, 7. We'll say this is the first bad version, but how do we narrow it down to that the most efficiently? All right, so we have left, right, and a midpoint. So we check, is our midpoint a bad version? It's not, so now we know that we can eliminate this half of the data set. We do that by redefining left as this. So now the leftmost point can be the number 5, and the rightmost point can be the number 7. So we just repeat those steps again. We check if the midpoint is a bad version. It is, so now we know that we can eliminate anything to the right of it because the first bad version started either where we are now or somewhere to the left of us. So let's eliminate here, and we'll reassign right over here. So now we're left with only two possibilities. Either 5 or 6 is the first bad version. So now we'll do the same step again. In this case, since there are only two elements, the leftmost element is considered the midpoint. So we check, is the midpoint a bad version? Yes, it is. And because the midpoint equals the same thing as the left element, so the leftmost element, we know that this is the first bad version. All right, so let's code out the solution. What LeetCode has given us is a function called solution, which accepts another function called isBadVersion. They don't show us the implementation of isBadVersion, but all we have to know is that this function returns whether or not the version we're on is a bad version. All right, we also see that it has an inner function. The reason they give us this is just in case we want to implement a recursive solution, but this time we're not doing that. Our solution is just iterative. Remember, the first thing we're going to do is we're basically going to define our data set from 1 to n. So we're going to have a left and a right. So we'll say let left equal 1 and let right equal n. Next, we'll loop over the elements in our set. So while left is less than right, what are we going to do? Remember, the first thing we're going to do is we're going to create a midpoint. So let mid equal, and we'll use our midpoint formula. So left plus right minus left. Put that in parentheses. We're going to divide right minus left by 2. And then we're going to wrap that in math.floor to round it down. All right, so that would put us at our midpoint. Now we'll say if the version we're on is not a bad version, we'll narrow down our data set to only the right half. Because if the midpoint is not a bad version, the first bad version is to the right of it somewhere. All right, and that would look like this. Left equals mid plus 1. We're not done implementing the rest of the body of this while loop, but since we've already showed you what happens in the if statement if this is not a bad version, let's move on to the next loop. So what happens in the first step of the while loop? We create a midpoint, so that'll be this. Then we go back to the if statement and check if it's not a bad version. In this case, it is a bad version. So because of that, we know that any data points to the right of it can't be the first bad version, since the version we're on right now is already a bad version. So we can eliminate the right half of our data set by pulling in our right variable by saying right equals mid. So that'll look like this. So now we're just down to 2 data points. Okay, so while loop starts again, we have a midpoint, which is this. We check if our midpoint is a bad version. It is, so we again pull in our right variable by 1, eliminating that half of the data set. And now look what we have. Our left and right variable are the same. There's only 1 data point left in our data set. So because of this, we know that we're on the first bad version. So what do we do now? All we have to do is return left. So let's run the code. Oops, I put right equals left instead of return left. Run it again. All right, looks good. Let's submit it. All right, so our solution was faster than about 86% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. See you next time.